Hello! In this video, we'll be taking a look at the Kubernetes integration in NeoLoad Web 2.3. The purpose of Kubernetes is to automate, scale, and manage application deployment. Here, in the context of NeoLoad Web, we'll be using Kubernetes as a dynamic infrastructure to deploy NeoLoad controller and load generators. For this demo, I'm using a self-managed Kubernetes cluster running on my local environment, but NeoLoad Web integrates as well with any fully managed services such as Amazon EKS, Google JKE, Microsoft AKS, and so on. Agenda for the demo. So first, we'll check the prerequisites in terms of version and the command line tool we'll use. Then we'll configure the Kubernetes cluster to create namespace, role, and service account. On NeoLoad Web side, we'll create the Kubernetes infrastructure provider and a new zone based on that provider. Then we'll run a test from NeoLoad Web with that new zone. And finally, I'll give you some advices on how to troubleshoot issues you may have with the deployment. So let's get started. First, let's make sure we have a kubectl. Kubectl is a command line tool for controlling Kubernetes clusters. It provides all the operations you need to create, delete, list the Kubernetes objects, such as the nodes, pods, namespace, and so on. Documentation is here. You can check out the kubectl cheat sheet. You'll find everything you need. In terms of version, we need a Kubernetes cluster version 1.9 or higher. We can check that with command kubectl version. And here I'm using 1.10.11, so I'm all set. Then second tool we need is a Helm. It's a package manager for Kubernetes. Version needs to be 3.0.2 or higher. You can check that with command line Helm version. Here I'm using 3.1.2. The Helm chart we provide is published on GitHub. It will create a role with the following rules and create the role binding and the service account. If needed, you can configure inside the values YAML file, the Docker registry URL, the username, or the password. So first step is to create a new repository based on that Helm chart. The command line is helm repo add. It takes as argument the name of the repository and the URL. The name of the repository, neotis-chart, and I use the URL of the Helm chart. We see the repository has been added successfully. Next step is to deploy the credentials with command helm install. It takes as argument the name of the chart archive and the name of the chart. So in my case, it's a helm install, my release, followed by the chart. Okay, it has been installed successfully. We can see the last deployed date, the status, the revision, and under section notes, some important information we'll use later. That's it on Kubernetes side. The cluster is now properly configured. Now let's jump on NeoLoad Web to configure the Kubernetes provider. You need to connect as an administrator account, and you need to have a valid license installed to access the dynamic infrastructure settings. So I go to the menu account, then tab infrastructure providers. I add a new provider, name my self-managed kube, for example. Type, I choose Kubernetes. API URL, let's go back to the command line output. The API URL is the Kubernetes master URL, which can be retrieved by this command line, kubectl cluster info. And my master is running on localhost port 6445. I copy paste the URL. Then API token, here it is. Get the API token by running this command. Copy, paste, I execute the command, and I got here my API token to fill on NeoLoad Web. Finally, the namespace. It's the one provided during the Helm install. In my case, it's my release. And I can now apply and see the new infrastructure listed there. Then let's create a zone. We go to the menu Resources, create a new zone, name it, for example, my cube zone, based on the provider just created. We can customize some settings. First, in terms of resource sizing, we can define the memory and CPU quota for both the controller and load generator pods. We have some predefined settings, small, medium, large, or you can configure with your own custom values. In my case, I'll go with a small infrastructure. Then the Docker images setting. Everything is optional here. It's needed if you want to plug to a private Docker registry. You can specify here the URL of the Docker image for controller and load generator, along with the secret to pull the Docker images. But here, as I'll be using the public images published on Docker Hub, I can keep all these fields blank. Then apply, and that's it. The Kubernetes zone is ready to use. Let's run a test based on that new zone. We'll use one load generator, start test. NeoLoad Web starts the dynamic infrastructure on our Kubernetes cluster, run the test, and then stop the dynamic infrastructure. All that is done automatically. While the test is running, let's go a bit further and inspect our Kubernetes cluster. I can use command kubectl describe nodes to have a verbose output of my node. Here I can see, for example, the CPU and memory usage of each pod. I can list the pods with command kubectl get pods, and I specify the namespace. That gives me the name and status of each pod. I see here that 2 pods are running, one for the controller and one for the load generator. Both are running fine. In case of error status, I can use the command kubectl logs to retrieve the logs of a specific pod. So it's kubectl logs followed by the name of my pod. Here, for example, I pick my NeoLoad controller agent and the namespace. That gives me the logs of my NeoLoad controller, seeing here that the test has been started successfully. That's it for today. Thanks for watching.